Hi all and welcome. For this PowerPoint, we're just going to go through it and have a look at individual plumbing fixtures, how to identify them on a drawing, and how to begin sizing them. Perhaps maybe step one, step two, if you wish to call it that, but it's certainly not extensive but it's meaningful. So let's start with the individual fixtures and we'll talk about what some of them look like, at least some of the main characteristics. We're going to talk about specifically, we're going to talk about reading a drawing for fixture information, some terminology and definitions that go with them, and some code versus common fixture terminology. Fixtures often have one fixture, has multiple terms that describe it, so we're going to talk about that. Then we'll move on to individual fixture sizes and loads, and then a little bit of system loading. You could consider this step one or two if you would. We're not going beyond that though. So we're going to talk about system loading, but it truly is just step one of system loading. If you want to call it step two of sizing after doing the earlier table, that's fine. But I consider it step one of system loading. It's where you just identify the individual fixtures on the system and give yourself a sense of what the loads are on that system before you start exploring all the outliers and all the other tables. Couple of general principles for loading, and we've talked about some of this terminology already, but for the drain and waste, you start from the most upstream or highest fixture in a building, and you simply tally the loads. As the waste comes down, it picks up another fixture and picks up another, so you add them up on a descending order, I call it, as you come down. With the vents, it works the other way because you're going up to get fresh air. So you start at the most downstream fixture, the lowest fixture in the building, and you work your way up in an ascending order as you add those up. Anyways, keep your eye on that. And again, we're going to practice this, so you don't have to memorize it. To give you a sense, A, the waste from A, which is this list of fixtures, would come down, it would fall, and then it would pick up B, so you add that in. And then it would pick up C. And then those three would come down, the waste from those three would come down, and it would pick up D. So stack B, essentially, would be A, the waste from A, fixture units I'm talking here, fixture units from A, plus B, plus C, plus D, equals stack B. So that's what I mean by descending order. Now, if you had a vent pipe going the other way and heading out the roof, right, there'd be, say this is the roof here, so you got a big pipe up here. Maybe it goes a little bit smaller underneath, I don't know. We'd have to check our sizes. But here, where these fixtures are, you'd have the smallest number of fixture units. And then when it picked up these fixtures, and then these fixtures, and then these fixtures. So if it was B, so in this case, it would be D plus C plus B plus A, so in ascending order. So we're going to try a little bit of one here. So get your code books handy. We're going to start with 7493. So open up to that. And I don't know if I'm going to do all of them, but I'll at least do, I don't know, at least one of them. So let's start with A. And we have 1, 2, 3, 4 types of fixtures. And we have 1 service sink, 2 floor drains, 4 lavatories, and 2 drinking fountains. So we'll start at the top here with 1 P-trap service sink. So I've already told you that a P-trap is a fairly lightweight fixture. It's not going to be a heavy duty one. In this particular case, they've given us the size of 2-inch. So that's done. So now we just have to find that service sink on our table. Well, if you'll take a look, 7493, you take a look at item number 23. You've got two options. A just says domestic sink or household sink, and it's 1.5 fixture outlet pipe with 1.5 fixture units. And that's not it, because we've been told it's 2-inch. So take a look at 23B. It says other sinks, and it gives us 1.5 inch is the minimum size. But then when you come over to the final column, the fixture unit column, it says simply 1.5 fixture units with an 1.5-inch trap, or 2 fixture units with a 2-inch trap. So that's what we have here, 2-inch trap, right? So that's the one we're going to use. We know it's 2-inch. We only have one of them. So that is 2 FUs. That's it. Then next one, you can go to floor drains. That's F, so it's going to be a little bit higher up. Item number 15. Default minimum size is 2-inch. Minimum. I usually use 4-inch, but the code says 2-inch, so we'll go with 2-inch floor drains. There's 2 of them, and they are 2 fixture units each, which gives you a total of 4 fixture units. I guess I can put a little caption up here. These are FUs. There you go. FUs. Total FUs. So this is the total for branch A. Now we've got lavatory basins. We might have done lavatory basins already, I'm not sure. But they are going to be a little bit beneath F. So it's item number 19. I'm just going to go straight to C, which is the domestic type. If you'd wanted to, you could have stopped at B, the dental, because it's 1.25 inches. The same as the C is 1.25 inches. But you could not use A, the barber or beauty sink. That's those neck sinks you lie back in the barber shop, because it's 1.5 inches. So that's bigger than minimum. So we're going to go to C, domestic type single, or 2 singles with a common trap, which would be that continuous waste we talked about earlier. It does in fact have an 1.25 inch waist. I don't have enough room here in my marker. 1.25 inches. And that's for the lavatories. And then if you look off to the side there, it says 1 fixture unit if you have an 1.25 inch trap, 1.5 fixture units with an 1.5 inch trap. So we're going to use the 1. And there are 4 of them, which gives us a grand total of 4 fixture units for those 4 lavatories. The last fixture here is the drinking fountain. You can go up to number 13 for drinking fountain, and you will find that it too is 1.25 inches. But the hydraulic load is just 0.5. There are 2 of them, so that's 1. So branch A then would have a total of 2, 6, 10, 11 fixture units. FUs. So what would be the minimum size? What would be the minimum size of branch A to start. So this is what I call the default minimum. But it can't be any smaller than the last fixture served. So if it has a 2-inch P-trap in it, can you run it through an 1.25-inch drain? Absolutely not. The largest pipe served is the smallest size allowed. So it's 2-inch default minimum, or dumb. And it's just a starting spot, right? Again, there's lots of other tables to check it against and then outliers on top of it. But for now, I guess I should put my little sign up there. It would be a 2-inch default minimum. So the last table I want you to look at now is go to 7571. That's the venting table. The absolute smallest pipe size for A is 2-inch. Therefore, you can use that largest trap size to identify how big the vent has to be for this. If you look at 7571 under column 1, the largest trap served is 2-inch, which is item 3. Therefore, the vent size can be no smaller than 1.5 inches. I'm going to run out of room here. And that's also a default minimum. It may in fact have to be larger. But again, these are your starting sizes, right? Based on the individual fixtures. There you go. Excellent. And then you can do the same thing for the distribution. So next up, and I'm not going to do all of this, but I just wanted to give you a sense of how you add up in an ascending order, so an upward order, right? And for this one here, I'm going to suggest that we just use, something at the bottom. So maybe we'll just use, I don't know, the shower stalls or something. Yes, we'll use the shower stalls. That looks good. So again, go back to 7493 and take a look at shower stalls. So as I'm looking through here, the only thing I see here is item number 22, shower drain. Do you think that's one and the same? Absolutely. Just because it's different terms doesn't mean it's a different fixture. So number 22, shower drain. A is 1 shower head, B is 2 or 3 shower heads, C is 4 to 6 shower heads. Again, we're looking for the smallest one, so we're going to go 22A. We're talking about venting here, but we have to know the size of the drain, which is 1.5 inches. So we can put that in here. So the default minimum for the drainage, or the FOP, if you will. FOP, 1.5 inches. The FUs, oh, that's not very bright. There we go. The FUs are 1.5. Therefore the vent, so now I'm just looking at 7571. For an 1.5 inch trap, you'd need an 1.25 inch vent. So those are your main numbers for this. And now so again, I'm just doing the shower stalls, but you start at your lowest furthest one, towards the bottom would be this one right here on the left. You got a shower stall with a vent pipe coming up off the shower drain, and it is 1.5 FUs. And then you get 1.5 FUs. Geez, my mouse isn't the best, eh? Anyway, so you get 1.5 FUs and 1.5 FUs there. This 1.5 fixture units, and remember this air is just in this pipe, right? So it's just serving this fixture at 1.5 FUs. It picks up a second one, therefore on this pipe, there's 3 FUs total being served. So this vent pipe right at this point here has to supply enough air that you can get 3 fixture units worth of liquid through that drain without clogging it up or creating an airlock or anything like that. So that'd be 3 fixture units there. Then so that's 1.5 plus 1.5 plus 1.5. Therefore, this pipe would be 4.5 fixture units plus 1.5. So this would be 6 fixture units plus 1.5. This would be 7 fixture units here. Right there. So there's enough air passing through this pipe to ensure that 7 fixture units worth of liquid flow nicely through the drain. And you just keep adding them up. Right? So I don't know, these are floor drains, a bunch of floor drains, a bunch of sinks. So you would take this number, whatever this is, I'm not going to work it out. You add all this up to get to here, and then you add that plus the 7. Take your total from here, add it to there, and that will give you this pipe. Then you take this one, add it to that one, and it gives you this one. And so on. You just keep going up, up, up as you pick stuff up. Anyway, so that gives you a sense of how to use the tables for that. We're not doing this drawing this semester. I just wanted to give you a sense of what ascending order was and how to add them up. Okay, almost there. An hour into this PowerPoint. Wow, not bad for 35 slides. I hope it shows up for you in such a way that you can kind of edit it out and find the things you want. Anyways, total distribution loading. So for this one here, we just have to identify the pipes that serve both the hot and the cold. So both of them. So essentially the water main. If you can find the water main to a building that goes all the way to the branch for the water heater, you're good. Then you simply tally those FUs beginning at the most downstream main pipe, or the highest and furthest. So you come back towards, you go to the furthest point in the house, like drainage, and you come backwards. Cold distribution is a little bit different. You do start at the most downstream fixture. And remember, downstream is the furthest one in the house in this case. It's reverse the drainage, because the water's flowing in, not out, right? So the downstream, upstream is backwards. Anyway, so you just go up there and come back until you get to that water main. I'll show you all this in a moment. And then hot, you essentially do the same. You go to the most downstream, highest fixture in the building, and you come back towards the hot water heater. So here's kind of sort of what it looks like. There's your hot water heater, right? And here's all your fixtures. So we got a 3/4 inch bathtub, heavy duty bathtub. We have a shower, water closet, lavatory basin. So this would be like an ensuite bathroom with a big bathtub in it. You got a clothes washer, laundry tub. You got a kitchen sink and a dishwasher. You got a hose bib outside. This looks like a regular bathroom with a water closet, a lavatory, and a bathtub. The hot water heater I did already, and then you got another outside tap. So the water main for this, it's an easy one, just goes to the first branch serving the water heater. That's it. That's your water main. So So all you have to do is go through these fixtures and find the total load. I think we did the laundry tub before. So the total load on the laundry tub was 1.4. The cold load was 1, and the hot load was 1. Right, so with the laundry tub it's 1, 1, and 1.4. So you take this so it would be this 1.4, and then there would be the same thing for the lavatory basin, which I think was 0.7. WC was 2.2. And you just keep adding up all those numbers, and that gives you your water main pipe size down here, the purple ones, right? For a lavatory, or sorry, for a WC, it doesn't have hot water, so the cold water load is also 2.2 because it's not a shared system. Lavatory basin is 0.7, or sorry, 0.7 total, 0.5 for the cold. 0.5. I'm just doing a few fixtures here, right, to give you a sense. 0.5 for the lab. So, you know that this is hot water pipe. That's easy because it's red. But think about what this pipe does. Does it supply cold water part of the system? Absolutely not. It's coming into the water heater. So this is actually red pipe. This is hot. Not because of the temperature of the water that's in it, but because of the system it supplies. It supplies the hot water system. So that's under the red. Again, you just go way out here and add them all back. Boom, 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 boom. And as I'm just going to make up a number here now. Let's say every fixture was 1. So this would be 1, 2, 3, 4, 5. Sorry, that was the wrong marker. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're just adding it as you come back towards the main supply. Anyways, hopefully that made a little bit of sense. But using that table rather than scrawling it all over the drawing like I've done is probably a little bit easier for you. We're not doing this drawing today. This is one you can use for practice if you like it. It's got some drainage and some venting on it. We might do it another day. And then this is just an additional slide. I like this slide because it just gives you a sense of what happens when you search for terms like water closet online. You'll get things like, sorry, we didn't find any results for water closet. It's because some of the terminology in the code book is only used in the trade, which tradespeople love, but really it's not very good to you out in the industry, just amongst the other plumbers. Anyways, that's it. That was an hour-long PowerPoint presentation that I hope to heck you can chunk it out and watch it as you need it in sections. My name's Jeff Rugrock, all things plumbing for you this semester.